Data science to production pipeline. In this video, we will look at overview of the ML workflow where data preparation to deployment. We look at experimentation versus production. We look at challenges in deploying ML models, and we'll do an hands-on where we'll do an end-to-end pipeline for an ML model. Let's jump into overview of ML workflow, data preparation to deployment. The machine learning workflow involves several key stages from data collection to deployment in production. Here's a breakdown of each step. Data preprocessing. Data preprocessing involves cleaning and transforming raw data to make it suitable for training a machine learning model. This stage includes handling missing data, example filling missing values or removing incomplete records, data normalization or standardization, encoding categorical variables, splitting the data into training and testing sets. Then we have model training. This step involves selecting a model type, example regression, classification, or clustering, and training it on the data prepared. Supervised learning uses labeled data to train the model, while unsupervised learning works with unlabeled data. We also have hyperparameter tuning, which may also be a part of this stage to optimize the model's performance. Next, we have model evaluation. After training, the model is evaluated to assess its accuracy and performance. Common metrics include accuracy, precision, recall. There's also F1 score for classification task or mean squared error MSE for regression task. Cross-validation is often used to ensure the model generalizes well on unseen data. Model deployment. Once the model is trained and evaluated, the next step is to deploy it in production. Deployment involves packaging the model into a container, example Docker, for easy scaling and distribution, exposing the model as an API that can be consumed by various applications, and monitoring model performance in production, including retraining if the model performance declines due to concept drift, which is changes in the data distribution. Next, let's look at overview of a basic ML pipeline. A basic ML pipeline automates the entire process from data ingestion to model deployment. An example of a basic pipeline includes the following stages. Data ingestion, where you collect and load data into a processing system. Example, you put it in CSV, files, or databases, etc. Next, we have data preprocessing, where you clean and prepare data for model training. Next, we have feature engineering. Create additional features or select the most relevant features in this case. Model training, where you train the machine learning model. Model evaluation, where you evaluate the model's performance on test data. We have model tuning, where you tune hyperparameters for optimal performance. We have deployment, where you deploy the trained model to serve predictions in production. And then we have monitoring, where you track the model's performance and update it as needed. Experimentation versus production. What are the differences in tooling and processes? First is the experimentation phase. Tools like Jupyter Notebooks, local data sets, and frameworks such as Scikit, Learn, or TensorFlow are often used in this phase. Experimentation is primarily focused on building and testing models with small data sets, exploring feature engineering, and understanding data patterns. Versioning is often manual, with multiple iterations happening in local environments. Next, we have the production phase. In production, the focus shifts to scalability, reliability, and automation. Tools like Kubeflow, MLflow, or TFX are used for building scalable ML pipelines. Continuous integration and continuous deployment (CI/CD) pipelines are employed to automate the training and deployment of models. Infrastructure needs such as model serving, API management, and resource scaling are key considerations. Next, transitioning models from experimentation to production. First is code refactoring. Code written in experimentation might need to be cleaned, optimized, and modularized for production. Your scalability, where experimentation is done on limited data sets, while production models might need to handle large-scale real-time data. Monitoring, Production models require monitoring to track their performance and detect and any potential drifts in data or performance drops over time. Automation. Automated pipelines are essential to ensure seamless retraining and deployment when new data is available. What are the challenges in deploying ML models? One challenge that comes in mind is scalability, where ML models might work well on small data sets but struggle when scaled to handle massive amounts of data. And deploying models that need to serve predictions in real time can require significant infrastructure. Next is reproducibility. In experimentation, results can vary depending on factors such as random seed initialization, data sampling, or hardware differences. Ensuring reproducibility means being able to consistently recreate the same model performance across environments. Reliability. Models deployed in production must be reliable under varying loads and data inputs. There are risks of concept drift where the model's performance degrades as the input data changes over time. Let's jump into hands-on, which is our end-to-end pipeline for an ML model. Our goal here is to build an end-to-end machine learning pipeline that includes data pre-processing, model training, and evaluation using Python and Jupyter Notebooks. The example that we will focus on is based on housing price prediction model in California. So the steps that we will follow here include data pre-processing. Next, we'll look at model training, model evaluation, and finally, we'll save and load the model into production. Data pre-processing, but before doing that, let me go ahead and create my environment. So I'm going to create a Python -m virtual environment. I'll call it uh, path to production prod, and I'll source it. Source path to prod slash bin slash activate. Clear this out. Now, first thing that I want to do is I want to do all the data pre-processing in Jupyter Notebooks. So what I am going to do is I'm going to first install. So if you don't have Notebook install, that can be done using this command pip install notebook. It's going to take some time, and once it's done, what you're going to do is next step is open the notebook by saying Jupyter Notebook, and that will open your notebook something like this. And here I'm going to say file, new, notebook. I say Python 3, perfect, select, and I'm going to give it a name here. I'm going to say path to prod, something similar. Now, our steps that involve here is first was, as I mentioned, the first step is for data pre-processing. So what I'm going to do is I am going to go here and first import the required libraries. Import pandas as PD. Next, I want from sklearn dot model underscore selection import train test split. So let's go over this before I go too much in deep. Now import pandas as PD. This imports the pandas library, which is commonly used for data manipulation and analysis. It provides the data frame structure to work with the tabular data. And the second line, which is from sklearn model selection import train uh, test split. This imports the train test split function from sklearn, which is used to split the data set into training and testing sets. Let's go to the next one, which is from sklearn dot pre-processing import standard scalar. Spell it right. Let's see. So this what this does is this imports standard scalar from sklearn, which standardizes features by removing the mean and scaling them to unit variance, that is mean equal to 0 and variance equal to 1. This is crucial when using models like linear regression and neural networks that assume normalized data. And now the last one, which is from sklearn dot datasets. You can probably tell what it is for import fetch California underscore housing. Just from the name, you can probably say that this imports the California housing datasets, a popular dataset used for regression tasks. It contains data such as house age, median income, and house prices in California. So that kind of takes care of our first items. Next thing that I want to do is load California housing dataset. So we have the libraries imported, but we have not yet loaded the data. So for that, I am going to say create a variable housing equal to fetch California underscore housing. What this does is this fetches the California housing dataset. The dataset is loaded as a dictionary-like object with attributes such as data, which are features, and target, which are like house prices. Now I'll take that data, pd dot data frame, and I'll get housing dot data from above and columns equal to housing dot feature underscore names. So this converts the housing dot data, the feature of the data set, into a pandas data frame. The columns equal to housing dot feature names assigns meaningful column names like let's say if there's med inc for median income, house age, etc. for house age. So that's what this does. And then next thing that I'm going to do is I'll say data price equal to housing dot target. So this is our target variable. This creates a new column called price in the data frame where the values are the target variables, that is house prices. This column will be a dependent variable that the model tries to predict. Okay, so let's go to the next part, which is print data dot head. So if I run this now, oops, I'm missing one. Okay, there you go. It's gonna fetch that. I think I have some error here. I guess my typo here, standard scalar. Let me try again. And here I have some error, housing dot data comma columns equal to, let's try that, and there you go. So we have our data dot head. So that is displayed here. Next thing that we want to do is split data into features and targets. So what I'm going to do here is I'm going to have x equal to data dot drop, and I am saying that drop price axis equal to 1. Now this, what this does is here the features, which is the independent variables, are separated from the target variable. The drop price axis equal to 1 removes the price column from the data frame, leaving only the feature columns like median income, house age, etc. in the x variable. And then I'll also create the y variable equal to data of what will go here. I think you know what will go here, that is price. So if you don't know what I'm doing here, this assigns the target variable price, house prices, to y, which will be dependent variable that the model learns to predict. Next, let's go ahead and train test split. Let's do the train test split, which is I can say x train comma x test comma y train comma y test equal to train test split x comma y comma test underscore size equal to 20% of it. And then for random core state equal to 42. So here what I'm doing is this function splits the data into training and testing sets. Test size equal to 0.2, which I mentioned, means 20% of the data will be set aside for testing, while 80% will be used for training the model. The random state 42 ensures reproducibility by making sure that the random split is always the same when you run the code. So that kind of takes care of that. Also the variables x train, y train. X train will have 80% of the features used for training, x test will have 20% of feature used for testing, y train 80% of target values for training, and y test will be using the 20% of target values for testing. So that's what they will have. Next, what we want to do is we want to scale the features. So I'm going to go ahead and say scalar. Let's make sure that I don't misspell again. Standard scalar. This initializes a standard scalar object. This scalar will normalize the data, ensuring that each feature has a mean of 0 and a standard deviation of 1. Next step, I'll say x train scaled equal to scalar dot fit transform x underscore train and x underscore test underscore scaled equal to scalar dot transform x underscore test. So the x underscore train scaled, this fits the scalar of the training data, which is the fit, and applies the transformation, which is the transform, to standardize the features in the training set. Whereas the x test scale, this applies the same transformation to the test set as was applied to the training data. It uses the statistics mean standard deviation from the training set to ensure consistency. So this kind of covers our entire, can probably run this just to make sure that everything is fine, and it looks like it did go through. So that's good. That's kind of covers our step 1, which is data pre-processing. Now the next step that we will be doing, second step, is model training. So model training, first thing that we will do is we will import the model. So what I'm going to do is I am going to first sklearn dot ensemble import random forest regressor. What this does is this imports the random forest regressor, a robust ensemble learning model used for regression tasks. It fits multiple decision trees on random subsets of the data and averages the results to improve accuracy and reduce overfitting. Next thing that we'll do is initialize and train the random forest regressor. So with this here, I am going to say model equal to, copy this, so random forest regressor n underscore estimators equal to 100 and random underscore state equal to 42. Also write the next one, let me explain you in a second. Model dot fit, and inside this fit I'll fit my x underscore train and or underscore scaled and y underscore train. So what I'm doing here is in this line, this creates an instance of the random forest regressor model, and n estimate is equal to 100 means the model will build 100 decision trees and average their results. That's what it does. You can increase, reduce, whatever you want. And random state 42 ensures that the results are reproducible. Next, model fit. This trains the model on the scaled training data, x trained scaled, and the target values y trained. The model learns patterns in the data during this particular step. So that kind of covers our step 2. Now let's go to step 3, which is, so I'm going to just run this. So step 3 is model evaluation. So training and everything is done. While it's doing this, I can probably start typing. Yes, perfect. So that's done. So next thing is model evaluation. So I am going to import sklearn dot metrics. So I'm trying to import evaluation metrics here. The import mean squared error and r2 I think it's underscore score. Yep. So what I'm doing is this imports two common evaluation metrics for regression task. First one is the mean squared error, which is MSE, which measures the average squared difference between predicted and actual values. And then we have the R squared, which represents the proportion of variance in the target variable that the independent variables explain. And R2 value close to 1 means the model fits the data pretty well. So next what we are going to do is we are going to make the predictions on the test set. So from here y underscore pred equal to model dot predict, pass the x underscore test underscore scaled. So this generates predictions, which is ypred, for test data using the trained random forest model. These predictions will later be compared with the actual values, which is a y-test, to access the model's performance. So now let's go ahead and calculate the mean squared error and r square, which we have imported. So I'm going to say MSE for this particular case is mean squared error. I hope it's typed properly. Yes, perfect. And in that I will pass y underscore test and y underscore predicted values. And then for R2 I am going to say R2 underscore score. I'll say y underscore test and the second parameter underscore pred. So just to go over this, the first one, this calculates the mean squared error by comparing the actual house prices, which is y test, and the predicted, which is y pred. And this calculates the r squared score to evaluate how well the model explains the variance in the target variable. So now let's go ahead and print our evaluation metrics. I think that is nothing to explain here, but mean squared error is the value is MSE, and close that. And the next one is our r dash squared, and this one is r2. Perfect. And let's run this. And we have the mean squared error to 0.2555 and r squared to 0.804. Now that kind of completes our step 3. Now what we are going to do, so step 3 was model evaluation, so we're done with model evaluating, and next thing that we'll do is save and load the model. So for that I need to first import joblib. Joblib is a Python library for saving and loading data, large Python objects such as trained machine learning models. So that's what I will be using here. I'm going to save the trained model, joblib dot dump, pass the model, and I'll call the model, let's call it California housing underscore model dot pkl, which is a pickle file. So here this saves the trained random forest model to a file which was California housing model.pkl on disk. This file can be loaded later without retraining the model. So let me run this, and you'll see on my desktop this file was created. Now next step is, what if you want to load that file? So to load it, you create a variable loaded model equal to, you can use same joblib dot load, and you give the file name. I'm not gonna try to type that out, and that, so this loads the saved model from the file back into memory, so you can use it again without retraining. So you don't have to go through all these things. Once you have this file, you can directly run this code using the joblib and load it. Now next step is using the loaded model to make predictions. So how do I do that? So I can go here, I can say loaded model predictions. Let's type the entire thing. I'm going to say loaded underscore model, that's the variable, dot predict x underscore test underscore scale. So I'm going to use that to run it. So this uses the loaded model to make predictions on the test set again, verifying that the saved model performs the same way as the original model. And I can then, to verify it, I can print it out. I'm going to say predictions from loaded model is, take this loaded model predictions, and I'll get the 5 of them. Close this. Oops, I think let's see. So that square bracket is closed, this is closed, this is closed, and then I have to close this. Perfect. So this prints the first 5 predictions made by the loaded model, allowing you to verify that it works as expected after loading. So let's run it up. And it says prediction model. It will give you the first 5 of them, 1 2 3 4 5, and gives the predicted values for this. So this kind of completes our 4 steps, where we started with data pre-processing. Right on the top, we started with data pre-processing. Then once the data was pre-processed, we did model training, which was right here. We started with the model training, and after the model was trained, we did model evaluation, and then finally, once the model evaluation was done, we saved and loaded the model and asked it to predict again, just to make sure that everything is perfect. This kind of concludes our topic on data science to production pipeline. If you have any questions or had any issues while running this code, let me know in the comments and I can help you out. If you're missing any libraries or anything, do let me know and I can help you out.